Hello, today I wanted to do a math proof on why this formula works. I want to prove why the multivariable chain rule is as follows. So we have the derivative of multivariable function f of xy with respect to ds, which is equal to the partial derivative of f with respect to x times dx over ds plus partial f partial y times the y ds. And this can work for however many variables you want, but for simplicity's sake I'm going to keep it as just a two variable function. So first, I want to recall the definition of partial derivative. So let's say that we are only to change with respect to only one variable. So we're going to keep y as constant. So this is going to look like this, like this. Partial f partial x, and this is the limit as delta x goes to 0, and this is a limit definition of partial derivative. But now I want to tailor this so we can do the proof. I don't want to do that. First, let's multiply on both sides by delta x. So we're going to get f of x plus delta x, comma y minus f of x y is equal to partial f over partial x times delta x. And now we can solve for f of x plus delta x, comma y, and we add f of x, y on both sides of the equation, and we're going to get f of x plus delta x, comma y is equal partial f partial x delta x plus f of x y. Now, instead of keeping y constant, we are going to change with respect to our variable y and keep x plus delta x as constant. So if we do this again, we're going to get, look, I'm going to skip all this process we did here, but basically we're going to get x plus delta x, comma y, y plus delta y, and this is going to be equal to partial f partial y delta y plus f of x plus delta x, comma y. But we know that f of x plus delta x, comma y is equal to this. We already have an expression for f of x plus delta x, comma y. So we can plug this equation into this one, and we're going to get that f of x plus delta x, comma y plus delta y is equal partial f partial y delta y plus, and we're going to get partial f partial x from here, also delta x, plus f of xy, f of x y. Now let's move this to the other side of the equation by subtracting f of xy on both sides. So we're going to get f of x plus delta x, comma y plus delta y, which is minus f of x, comma y, which is equal to partial f partial. I'm going to swap these two because I like having the x first, but remember that the order of the addition doesn't matter. So partial f over partial x times delta x plus partial f partial y times delta y. And now we're left with this expression. Now, what we can do now is divide on both sides by or change in the or parameter s. Remember that we are getting the derivative with respect to s, and also remember that our variables depend on this parameter. So let's divide by delta s on both sides. I'm going to distribute the denominator on both, so I'm going to get this partial s. And now remember that this was the limit as delta x approached 0, and so is this one, but for delta y approaches 0. And now we're going to say that this is a limit as delta s approaches 0. And since both delta x and delta y depend on delta s, these are going to turn into derivatives. So now I'm going to copy this. Like this. And we're going to get that this is equal to partial f partial x times dx over ds plus partial f partial y times dy over ds. And also don't forget that this is a limit as delta s approaches 0. So, but this over here is nothing but the definition of the total derivative. So this over here is equal to df over ds, which is equal to partial f partial x times ds over ds plus partial f over partial y times dy over ds. And that's it. That's why the multivariable chain rule is as it is. And I hope you might find this helpful, because sometimes it is harder to understand a mathematic problem if you don't really know where the formulas come from. So from me that will be all. So see you guys.